Here I am going to explain a couple of points regarding Game2. The essence of Game2 is the same as Game1, but there are some additional features in this game that I explain. First of all, I have designed this second game very sensitive. So before the game starts, you need to do all your computations. If you postpone it, I really don't think you can ever get among top 10 teams. Do all the computations before the game starts, and then at least for the first day, follow the game closely, maybe every 2 hours. And then gradually you can make it every 4 hours, every 5 hours. Depends on the situation. If you find it out that variability is high, then you need to watch more frequently. I start from here, incoming jobs. In this game, we have 3 types of contract. Right now, you are on the most inexpensive contract. For each job, if you deliver it in 3 days, you will get $750. And if it passes 6 days, then you collect 0. And your income, your revenue from 3 days to 6 days comes down linearly. The other contract that you have is 1 day and 3 days. So if you deliver it in 1 or less day, you get $1,000. But if it passes 3 days, you get nothing. The most lucrative contract requires you to deliver the product in half a day or less, and if you deliver it in 1 or more days, you collect nothing. But if you deliver it in less than half a day, you collect $1,250. You can switch from one contract to the other, but when you switch, all the jobs that you have already accepted and are inside your system, they'll follow the contract that they have been accepted. Only the new jobs will go on the new contract. And you can frequently go from contract 1 to 2 to 3 to 1 to 3 to 2 as many times you want, but always a job accepted based on a contract will remain on that contract. Therefore, if you look at the jobs that you are completing, maybe you are completing a combination of all 3 jobs because in a short period of time you have switched between 3 jobs. At the beginning, the maximum work in process is 25, and you can change it to lower or higher value. And you can go from one contract to the next by clicking on the appropriate contract and say OK. Here we have 2 menus. These are job arrivals, but these are not all the jobs that they have arrived, because our maximum work in process is equal to 25. Therefore, if you already have 25 loads inside the system, the next contract will not be able to come in. And it will not stay over there for a room. As soon as you don't accept it, it will go away. So if you want to know what the total demand is, then you need to download this data, for example, in column B, and then go here. These are the jobs that were rejected because you didn't have enough room for them to come in. Your WIP was 25 and you have rejected these jobs and they have gone away. But if you want to know the demand, you need to download these jobs too. And then, for example, they go to column C, then column B was jobs which have come in, column C jobs that you have rejected, and in column D you need to add these two to know what the actual demand was. One other window which we have it here and we didn't have it in the previous game is plot WIP. WIP is already set to 25, but that is maximum WIP. Your system does not allow more than 25 load in different places. For example, you have 25, an order comes and you cannot accept it. Then you send one job completed, you send it out, you now have 24 inside your system, but there is no incoming job because the one that came, you rejected it. For a while, it is possible that your WIP is less than 25. And in general, your WIP, if we look at it as average work in process, is less than maximum WIP that you have set it to 25. Therefore, while maximum WIP is 25, your average WIP may be 24.2 or something around that. How do you know what is the appropriate, the maximum WIP for your specific case at a specific time? Depends on what contract you are. For a minute, suppose capacity of this system is 5 jobs per day. So that is capacity. Let's assume this is equal to throughput. And suppose we are on contract which we are supposed to deliver it in 3 to 6 days, and if we deliver it after 3 days, revenue will come down. Therefore, we are willing to deliver it in 3 days. Therefore, we want our flow time to be 3 days, while we assume our throughput is 5. Throughput times flow time is equal to I, and that is equal to 5 times 3 equal to 15. Therefore, the average WIP should be 15 or less. In the previous game, we always were multiplying this by 1 because it was the flow time that we intended. In this game, sometimes we multiply it by 3, sometimes we multiply it by 1, and sometimes we multiply it by 0.5, because if you are on the most lucrative contract, average flow time should be 0.5. So that is the work in process, and we may set it as max work in process. But the average work in process, if max work in process is 15, average work in process will be a little bit less than 15. It is always recommended that after you set the maximum WIP, have a close look at it. Sometimes you can increase it by 1 or 2 units. Sometimes it is better to decrease it by 1 or 2 units depending on variability of the incoming orders. One other thing you should be careful is R is not equal to WIP. So while your WIP is 15, R could be 20, because the relationship between R and WIP is regulated through the flow time. Flow time times throughput is equal to work in process. And also note that processing time are not deterministic. When you find the capacity is 5, if we divide 24 by 5, which will come out 4.8, that means on average every 4.8 hours we send one product out, but it is on average. Sometimes we may send every hour a product out because the processing times are not fixed, are not deterministic. They may come down or they may go up, but the average remains the same. Let me here explain one other thing. Suppose you have computed the average inventory, and average inventory came out 3. And suppose you have computed the capacity, or you have assumed throughput is equal to capacity, and it has come out 5. Therefore, that means 5 times t equal to I, and t is equal to 3 over 5 day. If you multiply it by 24, that would be 14.2 hours. 14.2 hours. That is flow time. But suppose capacity of one of your stations is 5, capacity of the other one is 10, and capacity of the last one is 8 product per day. Therefore, this one, 24 divided by 5 is 4.8. 24 divided by 10 is 2.4. And 24 divided by 8 is equal to 3. Therefore, your product has no other choice to remain for 4 hours on average on a machine in station 1, for 2.4 hours on a machine in station 2, and for 3 hours on a machine in station 3. Therefore, the theoretical flow time, 4.8 plus 2.4 plus 3, which is equal to 10.2. Correct? But flow time, we found it is equal to 14.2. That is the theoretical flow time, the time that product must stay with servers on average. This is the time that it has stayed in server and in waiting lines. Therefore, the difference, which is 4 hours, is the time that products have spent in the waiting line. And that is the difference between theoretical flow time and flow time. Now, suppose throughput is really 5. Because theoretical flow time is 10.2, if I multiply that by 10.2, that is 5 per day, but 10.2 is in terms of hour, therefore I should divide it by 24. This is throughput. This is theoretical flow time. If I multiply them by each other, I get an I. That I, we call it pipeline inventory. That is the minimum inventory that your system must have, because they are with the processors. 24 is almost 5 times of 5. Therefore, 10 should be divided by 5. That is around 2. Around 2 units are always there if you are producing. That is the minimal inventory, which we computed based on throughput and theoretical flow time. If you have questions regarding these concepts, you may contact me and I explain more. One other responsibility that you have is to compute how much do you order and when do you order. Right now, whenever your inventory on hand reaches the raw material required for 24 jobs, the system automatically places an order for 120 jobs, and because each job requires 60 units, that is 7,200 kits. To compute EOQ, you need S, which is cost per order, and that is $1,000. You need D, demand, per year, per month, per day, You have demand per day. Suppose demand per day is 16. If I multiply by 30, that would be 480 per month. I can put D in terms of demand per month into my formula. The only thing I need is to transform also H, carrying cost per unit per year, to carrying cost per unit per month. Let's first see what is carrying cost per unit per year. Each unit of product requires 60 kits and each kit costs $10. Therefore, raw material for a product costs $600. You need to take that money out of your resources. On your financial resources, you are gaining 10% profit or interest or whatever it is. That is the opportunity cost of your money, of your cash. If you put it into raw material, 10% times 600, that would be $60 per year. $60 per year, if you divide it by 12, is $5 per month. Therefore, EOQ is equal to square root of 2 times D, which is demand per month here, 480, times S, which is $1,000, divided by H. Because here you have put demand per month, you should put H in terms of carrying cost per month, and that will give you EOQ. After you found your EOQ, you replace this 7,200 by your EOQ, and you need to update this EOQ as game moves forward. Then you need to compute ROP. You need to download actual demand, which was jobs that you have accepted plus jobs that you have rejected. You have it for 50 days. You can use average and standard deviation of sample. Functions of Excel, you can compute average and standard deviation. Now you have average and standard deviation of daily demand. The relationship between average and standard deviation of daily demand, which we show them by R, and sigma of R, that is average and standard deviation of daily demand. The relationship between these two and lead time demand, average lead time demand, and standard deviation of lead time demand. Standard deviation of lead time demand. Lead time demand is equal to R. For example, in this situation we said assume it is 16 per day, multiplied by lead time, which is 12 days. That is average lead time demand, and you should update it continuously. Standard deviation of lead time demand is equal to square root of lead time multiplied by standard deviation of daily demand, and therefore that is equal to standard deviation of lead time demand is equal to square root of 12 multiplied by standard deviation of the daily demand. Let's assume you have got it equal to 5, so that should be multiplied by 5, and that would be standard deviation of lead time. Now you have average demand during lead time, and you have standard deviation of demand during lead time. I encourage you to have a service level of 95, 99, something around there, because if you order some extra units and if you even keep them for 1 month, cost per unit is $5. That is your overage cost if you have the product but demand is not there yet. However, if you don't have the raw material and if you get a order, even if you are on 750 contract, you could have made 750 minus 600 equal to $150. This is your underage cost. This $5 is your overage cost. this underage cost, even for 750, is much higher than that 5, and therefore it is better to go for a large service level, 95, 99, something around that. But the situation is entirely different when you get to the very last 50 days of the game. When we go to the last 50 days, when you do not have capability to make any changes, you need to compute average and standard deviation of demand during those 50 days very carefully. So over there L is equal to 50 days, and then you have demand per day, and you have standard deviation of demand per day. Therefore, standard deviation of demand during that period, lead time demand, standard deviation of lead time demand over there would be square root of 50, because we are talking about 50 days, times standard deviation of daily demand that you need to compute it. In the previous situation I assumed it is 5, but you need to compute it. And also lead time demand during lead time is 50 days multiplied by average demand. We assumed for the first 50 days is 16 per day. Suppose for the last 50 days is also 16 per day, so that would be 800. And suppose this was 1.5, that was 50. Square root of 50 is almost 7. 7 times 5 is 35. So average demand during lead time is 800. Standard deviation of demand during lead time is 35. Then you need to find what is your overage cost. Overage cost is if you have the product but demand is not there. At the end of the game, if demand is not there, you have lost $600. What is your underage cost? That means if demand is there, but you do not have the product. And suppose you are on 1250 contract. So if demand is there, which could have gained you 1250, and product is not there, which its cost was 600, you will lose 650. This is underage cost, this is overage cost, and service level is computed as a probability which corresponds to underage cost divided by underage cost plus overage cost. Underage cost here is 650. This will be 650 plus 600. That would be a little bit more than 50%. Suppose it is 58%. Then you should set your service level equal to 58% and find this point. That is your reorder point. That is what you need to have on hand for the rest of the game. So you have this number, you go and look at your inventory, how much inventory you have, you subtract inventory from what you need. Also, don't forget to do this 1 hour, 2 hours before the game ends. Therefore, you should add the demand for 1 or 2 more days to this. For example, suppose it is 11 o'clock, you know how many units do you need for the next 2 hours and how many units do you need for the next 50 days or 50 hours in our life, but that last 50 hours takes 1 or 2 seconds. So we have it over there, and I compute what do I need. I set my EOQ equal to that value. I'll go to ROP and I set my ROP a little bit below my current inventory on hand, and then I wait. As soon as I produce 1 or 2 product, inventory on hand reaches ROP, as soon as I find it out that my last order was placed, I should go and change my quantity of next order to 1 million. Why to 1 million? Because you want to make sure that in the last 50 days, no order is placed. No order is placed in the last 50 days, because whatever is placed, if it is not used at the very end of the game, has a value of 0. All machines, all inventory at the end of the last 50 days have a value of 0. Okay, these games should be partially defined, but I think I explained a lot. The idea for this games is if we can leave our student in an undefined or partially defined environment, and if we can expect them to find their way out. Here I try to explain everything, but still you need to do these things dynamically for over 1 week and decide how to work with WIP, how to buy machines, and so on and so forth. As usual, I recommend you, if you make a mistake and buy a machine, stay with it, don't sell it, unless you really find it out that you do not need that machine. Thank you very much.